Hi, this is Jeroen, and this is Anchormen's AI journey. Tune in to get inspired by the opportunities, impact, and capabilities of data, machine learning, and artificial intelligence. Together with my colleague Ron, we will be talking about developments, best practices, and lessons learned from the field. So get ready. Welcome everybody to the third edition of the AI journey by Anchormen. Obviously, we have been a bit delayed by current events, but luckily we were able to find an opportunity of still recording the third episode in a very safe manner. We are here in a studio near Amsterdam Sloterdijk with 1.5 meters in between us, between me and my co-host Ron Dodge.
Hey, Jeroen.
And today we have a very special guest, namely Longhow Lam. How are you doing, Longhow?
Thanks, Jeroen and Ron. Thanks for having me here in this podcast.
You're welcome. You were on my list already for a while, obviously because you always post the most interesting tidbits about data science. Also not afraid to be critical of the industry once in a while, which I think is very healthy. We go back already for a while. I think we met during our time at RTL. And now we are currently also working together, at least Anchormen and you are, at our customer Adidas. But I just wanted to mention the first thing I ever heard of you was something you did with the soap opera Goede Tijden, Slechte Tijden. Can you briefly tell us about that, what you did there?
Yes, that is still my showcase hobby project, so to say. It introduces text mining and topic modeling in particular. Always when I want to explain people text mining and topic modeling, I take a lightweighted subject like Goede Tijden, Slechte Tijden. And I've analyzed all the summaries of all the episodes, more than 5,000, in a text mining, an LDA, latent direct allocation model. And I liked it because everybody understands Goede Tijden, Slechte Tijden, and you don't have to explain the context. So that is one of my hobby projects that I still often in guest lecture I teach to.
You still run that code?
Yeah, because Goede Tijden is still running.
Right.
Within 10 years, it's still actual. It's still.
What is it doing? How does it help you?
Well, it gives you an overview of what the whole series, 6,000 or 7,000 episodes, is all about, without having you to watch a single minute. Well, you have to run the code a little bit, and then you get the topics. You see what the subtopics are, what the main characters are, what the relation between the main characters are. And these are all, fairly straight-on text mining techniques, not that complicated even with deep learning or transformers. So plain good old school text mining techniques. And that's
keeping it simple. So basically you're providing a service for people to not have to watch the show, but still kind of know what's going on.
Where can I sign up?
Well, it's the code is on my GitHub, so
right. All right. So, but since then, you've transformed to, and I'm quoting your LinkedIn here, corporate AI, and
Enterprise AI.
Enterprise AI. Sorry, that's already
important difference.
Yeah.
Important difference.
And that's also one of the reasons why I really wanted to have you as a guest on here, is because we wanted to do an episode on data maturity. Which is a broad topic, and I thought Longhow is a guy. He's seen a lot of different organizations, and definitely has some experience to share, of course, with us. But maybe to start, because I think it also touches upon the topic of data maturity. What is Enterprise AI, according to you?
Well, if you read on my LinkedIn, it says, I don't know what Enterprise AI is.
You can charge more.
Because you can charge more, yes. And vendors doing this can charge more. Now, it started as a joke a little bit, but the last few years you see more and more people and also vendors claiming that they do Enterprise AI. But if you really if you really focus, if you really boil down what is enterprise AI, you can ask yourself, okay, these are the things we're already doing for the last 20 years, namely getting value out of data for a business and not just a hobby project. I mean, de goede tijden, slechte tijden, this is a hobby project, of course, that is not enterprise AI. But of course, if you do data science within a company, and we can talk about more of that, and you have aligned with the business, you have aligned with IT, and you know what you're doing, what kind of problem you're solving, to me, that is already a form of enterprise AI.
Absolutely.
So
maybe that's even the holy grail, right? Because the alignment with the business and with IT, that's often a bigger challenge than creating the models.
Yes, and so still, luckily I see it less and less, but still there are companies who just set up a data science team and do something not aligned with business at all. And they can do cool things. I mean, I've seen a lot of cool projects, but that is not enterprise AI. That is hobby AI, like I'm doing on LinkedIn, on goede tijden, slechte tijden. So that is a little bit of a difference. So and you can call that enterprise AI, but yeah, you could have invented another term. I mean,
no, I get it. So I think the term we've invented for it is that we mentioned it, the data activation triangle, which kind of comes down to the same thing. Although I think we're more on the tailor-made end of the spectrum, so doing a bit more the custom work. But basically, what it means is you can. We try to do projects that are right in the middle between software engineering, data engineering, and data science and AI. Because if you just produce a model in a Jupyter notebook, that's great, but how can you run it again, and how do you connect it to the rest of the organization? How do you supply it with fresh data, either in batch or in streaming? So it's often it also involves data engineering and software engineering. If you need to integrate it in an application, maybe.
Yeah.
And also, what gets thrown around a lot now, of course, is the analytics translator. But making sure that the organization actually knows how to use your project, that's often also a big challenge, because technology is very moldable, and you can adapt it completely to the organization as it is right now. But what have you gained then? I always say you want to kind of meet in the middle, up front.
Yes, true, and enterprise AI also has a nice schwung.
Absolutely, yeah.
So it's always good if you do enterprise things, of course.
Right. But it's not then necessarily bound to, I don't know, for you necessarily to maybe using certain tools. Although, of course, you can standardize it a lot, but it's more really bringing that value into production.
Yes, it's not bound to a specific tool or language. That doesn't make sense, right? You're doing enterprise AI only if you're using tools from a vendor, right? Of course, vendors would like that. But you can also do very good enterprise AI just using Python and following good CICD standards.
Yeah.
But so enterprise AI sounds as if it's a little bit like process, but in the end, it's about adding value to a company, right? They can use it, or is it more than that?
Yeah, well, that's a very short summary. At the end, of course, the enterprise aspect of it is of course, you're doing something for a company. And why are you doing this for a company? Because at the end, hopefully, the company will have more profit or less cost, right? That ultimately, in the end, of course, things might be different if you're working for a government, but if you're doing data science for a company and you cannot, at the end of the line, at the end of the day, you cannot say, I've saved you so many costs, or you gained some extra profit, then why did you do it at all? At the bottom line, right? But in the process, of course, you encounter cool projects. You do a little bit of research because you don't know if you can save money or have extra profit. So, but if you have a process in place where you can pull the plug quite quickly, and that also takes some courage to pull the plug from data science project, from any project, then I think that process is also part of the enterprise path that you're.
So what part of it is you doing enterprise AI, and what part of it is a manager leading a data science team or something doing the enterprise AI?
Yeah, I think the manager will eventually have to have the courage to say, okay, this project is not working anymore. And unfortunately, I've seen in the past a lot of projects that just continue, right?
Right.
The data scientist will have to say, okay, this project is not going anywhere. There is no value. The data is maybe not good, so we have to work on that. And then ultimately, the manager, the guy is responsible for this decision. And that, maybe in the last few years, it's improving. But yeah, still, most researchers will say that 60 to 80% of the data science projects will fail,
right,
or don't have the value out of it, right?
But there's a tension there, right? So there is, on the one hand, the data scientist who doesn't think the model is adding value versus maybe just using a model may already be better than what the company has been doing so far.
True, but if I may interpret Longhow's words, I think he mean it's not necessarily that the idea is not good. It's more that it's not achievable because of, for example, data quality issues.
Yeah, there might be several reasons why it's not achievable. Data quality is one. Maybe the model is not implementable in systems at the moment. Maybe the business wasn't aligned. That's what we said before, right? You're just doing thing. And a lot of data science projects I've seen started with a very good idea from the data scientist, building nice things. And then the difficult part is then to sell those models or sell those thoughts to the business. It should be the other way around. You should go to the business and say, okay, what is your business issue? And maybe data science can help. But that's, of course, tricky because maybe you don't have that many opportunities to work on.
Yeah.
While as you start with many ideas from data scientists, you always have some idea, right?
Yeah.
You can do goede tijden, slechte tijden.
Yeah.
So that's a struggle, and that's a balance you should find. I mean...
we sometimes at Anchormen we call this also doing evangelism work. So you need to go out into the organization and kind of talk to people and get their ideas and see how you can help them. So we often do them workshops with customers to kind of, well, hey, you know your business, we know the technology and the methods, and let's see where we can meet in the middle, and then also prioritize them through maybe first doing what you mentioned, also doing a cost saving project that can then finance a more ambitious project for, creating more revenue, for example.
So get the low-hanging fruits first, right?
Yes.
I mean, sometimes you also see people trying for the most difficult project because that's the most coolest thing to do. And that's not enterprise.
Right. So maybe looking at the Dutch market, do you feel, because you've been in the game already for a while, you've worked with SAS also, and then kind of moved on to maybe more plain Python, and now you do a lot also with data IQ. Do you feel that the Dutch industry or the Dutch landscape has matured more, that we have become more mature regarding data?
Well, not...
On average, obviously.
Maybe a little bit. And I'm saying this because when I started to work in 96, I went to a data mining conference. That was hot back in those days. And the thought was all companies will do data mining before the turn of the millennium. Because if you don't do it, you will have such a big... competitive disadvantage if you compare to your competitors, and you will fall, you will go bankrupt. But that never happened. I mean, companies went bankrupt, but not because they were doing too little data mining. So for the last 20 or even more than 20 years, we're still hearing this, we are on the first step of a revolution. Then it was big data, then it was data science, now it is AI. But every time you see people publishing sort of hype cycle, we're still at the beginning, right? It was 20 years ago, we were at the beginning of data mining, and now we are at the beginning of AI. So in that sense, not a lot of things have improved, if you look at it from a broader view. Of course, the industry has improved by there is more data, there are more fancy tools. You can do computer vision much more easily than 15 years ago, when it was really hard to do things and get data. But these are small steps. And still we're at the beginning now at the AI cycle. But if you look back 20 years ago, we were at the beginning of the data mining cycle. And I think still it's hard to get people really involved into these kind of technologies, whether you call it data mining or data science or advanced analytics.
So what does maturity mean to you? Data maturity. What does it entail?
To me, is that there is a business issue that can be solved by data science with data, and that around solving this issue, the company or the enterprise has done its work. There is a good data platform. People are willing to invest in it. There are people who can do this. And there is support from C-level, because you will run into issues that are not solvable by just the manager of the data science department. It goes more to the top, right? And then it's good that you have support from C-level to solve issues, because you're going to run into those issues that need solving from high C-level. So
you need a sponsor.
A sponsor, exactly. And to me, that means there is a maturity at that specific company. So it doesn't have to mean that, there is a difference between companies, of course. So that was 20 years ago also, right? You have companies who organized advanced analytics or data science quite well. And you have company that, they were not so well organized. And also today. So
that's a maturity in terms of I would say organization.
Organization, that is the most important thing. Yeah, the technique is there. It was there. It was 20 years ago there.
But is there also a requirement from your point of view on what? So you're saying there has to be a data platform. What else needs? If I have my data platform and I have an Excel on it with, say, 2 columns and 5 rows, am I mature, or when do I cross the line of being mature?
Yeah, it's hard to just.
I would say you could be if you use that Excel. Really, if you use it for decision making.
My answer would be it depends on the question that you have or the need that you have, right? So if I want to do some, I would say time series forecasting based on monthly data, that then determines the kind of data that you need. Yeah. Versus if you want to have, if you want to do deep learning, right? There are totally different requirements there. But is that part of maturity, or is that something that comes second? Organization first, and then the data will come anyway?
It's a combination. You can make a lot of money from simple Excel files, but I guess not a lot of data scientists would want to work with Excel files because they are messy. The logic is implemented inside the data. There are all sorts of arguments against Excel file, of course, but still.
But it also goes the other way, right? And I know you don't think like that. You just mentioned it as an example, Ron, but you're also not mature if you want to do deep learning. No, you want to solve problems that require deep learning.
Mm-hmm. Absolutely.
That's when you're really mature, right? If you're not necessarily doing it as a technology showcase, but if you really want to solve problems and then maybe also take like an iterative approach to because the simple things, like also on which I think again where the technological practices of the mirror the maturity of the organization is that a lot of organizations, they still don't have, for example, proper CICD in place. And what I've been preaching this already, I think on the Big Data Expo 2-3 years ago, where we can also incorporate data science into the CICD pipeline.
Maybe you can explain to some of the listeners what CICD means.
CICD, good point. CICD stands for continuous integration, continuous delivery. It's actually a practice from software development where you continuously are integrating the work of all the people working in your team. So all the developers, they're working on the code base on their laptops or workstations, whatever, and that needs to be integrated, right? And the integrity of your project needs to be guarded, and you need to make sure that that all the new features come together. And continuous deployment means that you then regularly have a deployable version of your project. Ideally, if you want to get really fancy, or it's not even, I would say now it's not even fancy anymore. It's best practice. You have several areas where you deploy your projects to, depending on the life cycle of your project. So you have your test environment, your acceptance environment, and your production environment, and all of this ideally even automated. And then the thing with data science projects, then you get into the territory of now what's called MLOps. This is something I think is kind of taking a flight right now.
Machine learning ops.
Machine learning ops, MLOps. Google just released a paper on this, also with a lot of the metrics that Ron, you and I have already discussed also. Like you should also monitor for data skewness, you should do A/B testing, for example. And all of this can also be automated, and you should also take into account when setting up your infrastructure.
Right, so MLOps is like CICD for data science, or is it more than that?
It's more, no, so I would say you can build MLOps on top of CICD, and there's
has
more
to be
it.
more than the traditional CICD for software engineering, because data science, okay, you're building a piece of software, not necessarily, but suppose, then it's with a traditional software development, you are testing features, right? Is there no bug? With a machine learning model that can be implemented perfectly without any bugs, and you put it into production, and it still can fail because of unforeseen new data, different customers that come to your company, and you also have to you also have to take that into account.
So how does that work? So we have our right. So software development is dealt with. We have CICD, and then So we have our models. And so how do we implement MLOps? Right?
So you need to, of course, it depends a bit on how literally you take CICD. If you only do it on the code producing part, so the models are building code. Do you do unit tests on top of that? Do you do integration tests on top of that? And then do you also do, for example, A/B testing and benchmarks? But as Longhow also mentioned, you also need to, next to that, monitor the data that's coming in, your production data. So the distribution of the data, is it still
performance of the model? Is it
performance of the model? Are you exactly what kind of predictions is it making?
So an example of distribution of the data would be I have a model, and my model works really well because it's been trained on data, say it's data from people, and the people are adults, and then your model works really well in making predictions for adults, and then suddenly your business decides to also use some product or the same product with children, and now suddenly data comes in from children with different age groups. So now your MLOps is supposed to do what? It's supposed to monitor that, to find that out,
and give out a warning.
Because otherwise the model
your
might not.
population is drifting. And your model may not work.
But I would go even one step further. There you can also automate a big part of that. Is that, of course, you want to retrain your model also periodically, right? Automatically. So, for example, every week or every month, you retrain your model. And those newly trained models also need to be monitored.
Yeah. So just for to make sure. So why is it the case? And this may be an obvious question to data scientists, but why is it the case that if I train my model on adults, it might not work for children? So you said your population is shifting. So what is the implication of that?
Well, suppose you train a model on only men, and now you decided to sell goods only to women. Then. I mean, it's not guaranteed to work. Let me put it mildly then. It doesn't... You could be lucky. The model could still work, but you're not sure. But it's more likely than not that because of a population drift, people have different behavior.
Yeah.
Your model is not captured. Your original model did not capture that, so you.
So you wanna make sure, right, that your model is trained on the data that represents the data that's actually used during production, right?
Yeah.
And then you go ahead.
During the training of the model, you can take that into account already a little bit, right? But the real testing is, of course, when the new data flows in.
Right.
Now, this wasn't an issue. I mean, 10, 15, 20 years ago, I created credit risk model for banks. You already had to do this. New people came in, new people wanted a mortgage, and your model was built on historical data, right? So that wasn't really an issue because you had maybe 1, 2, 3 models. So you could do it manually, and even with mortgages, the time scale is much slower. So it's in terms of years or months. Now, if you make decisions on a much faster on your website, click behavior, then you have a time scale that's much faster, and you potentially you can have much more machine learning models for different products. So then, yeah, you may end up with tens or hundreds of models, and that is not doable. So you've got to have an automated process to monitor.
Well, that's one argument. Furthermore, I'm a big believer of course, that if you with automation you can get rid also of a lot of human error, and if it's automated, especially for example, well, that was the reasoning behind, of course, deployments. With deployments, a lot used to go wrong, and if you script the deployment, there's unless of course there's an error in the script, but that will become obvious quite soon. You take out that factor, and I would say the same goes also for MLOps, where you can automate the deployment of machine learning models and also more quickly become aware of any issues.
It's actually interesting. If you take the point of view of an organization or a company, I would say that I would already be expecting that this is already the way that we've been doing things for years, right? I mean, it's weird that. So, for instance, making sure that the model is using to train the same data that it's using in production. I would say that's part of a mature professional field that's already happening. It's weird that it's now becoming a hot topic.
It goes back. Well, I think it at the one hand it goes to show the maturity of the field, that these things become important now. At the same time, it also shows the immaturity of, again, like a lot of the organizations, because just as with more conventional software development, there are also a lot of people are still not following the best practices, are still only doing trunk development in SVN, or right, so which means they only have one branch. They don't use any branching strategy or build server, and they just have the most senior developer,
right?
Create a deployment.
Question to you, Longhow: are you already using something like MLOps in your daily practice?
Bits and pieces. I mean, it also depends on the maturity of the company, and it also depends on what you exactly need from the whole MLOps philosophy. For some companies, it's going back to this example of credit scoring, so a model to score mortgage applicants. You can get away with it by having a model, a simple logistic regression model, and that is really easy implementable, and it doesn't need to be real time. You can score once in a month, and then the logic can be implemented, and usually is implemented in the database system. It's just one line of code, right? So just an addition and a multiplication. So then you can get away with it with not a fancy MLOps strategy. But if you're doing things online on the website, then that has to be in place. And I am a data scientist, so I usually not directly involved in these MLOps things. I'm not implementing the model directly into operational systems.
So maybe it's good to explain what is the thing that you do usually, and where is it being?
As a data scientist, yeah. I usually involved in talking to the business. What is your issue? I assess how can we help as a data science team. Can we help at all? I mean, some issues do not necessarily need data science to be involved. But then making the translation between the business and the data science model, so to say. Having a first investigation in the data, creating the models, and see if they work as a prototype, right? And I think, and that's where I think the last years people have realized that there's a strict distinction between a DevOps data engineer and a data scientist. Now you hear often that a machine learning engineer should be able to do everything, but still I think that is too ambitious.
Full stack data scientist.
Yeah, full stack data scientist, whatever you call them. I think these people are rare. That was 20 years ago. That is now. That will be in 20 years. So
yeah, I don't even think that a data scientist can do everything a data scientist should do without anything else to the stack. So you have, like, some data scientists are really good at machine learning. Others are really good at statistics.
Yeah, of course.
Right?
Even within data science, is a big field. Of course, you can do data analysis, more type of project. You can more statistical modeling.
Right.
NLP, computer vision.
Yeah, so you can't know everything, right? So
well, how we've defined it at Anchormen is that the machine learning engineers, they are not necessarily completely involved in the model finding. That's the work of the data scientist, but they productionize the output of the data scientist.
So they would be the ones that I can hand over my model to and make sure they implement ML ops, right? So,
exactly. Correct.
Okay.
Yes.
Yeah. Awesome. Let's have more of those.
Yeah, a handover also sounds like you're throwing things over the schutting kooi, over the fence.
Yeah.
That's a little bit exaggerated, of course, but it should be a close cooperation, of course.
Well, but let's assume, obviously, so that a data scientist would create a model in a Jupyter notebook that by itself can contain a lot of, or could become an accumulation of technical debt. So ideally, you want to take that out, and you want to have unit tests on top of that, build integration tests surrounding that. You might also need to expand on the model. It might need to be optimized. It might need to be made more performant. Maybe you need to port it to a different language because this was made in R, but it needs to run in Scala, for example. And then all this work is part of what the machine learning engineer would do.
Yeah. Yeah, I get
I mean,
that.
you work at Anchormen, you know.
I get that. Yeah, like just some separate side thought that I had there is that the bad reputation that notebooks get for productionizing, we can have a separate discussion on that, I think. But it's interesting to see that now more and more in these cloud services, we end up doing a lot in Databricks notebooks, for instance.
Yeah, and they are very happy with people letting them put it in production.
Well, I mean, these notebooks are just put into data factory pipelines, and they're actually used as production code there. So it's not so clear cut to me.
There are people who like notebooks and people who don't like it.
Do you like notebooks?
I'm in between. Because I think the messiness that notebooks can cause, it has nothing to do with notebooks per se. I mean, you can have a normal script, Python file. You can be as messy in there. But I think what you should do as data scientist is that the notebook is not. You should keep that in mind. That it is not necessarily immediately a productionized code, but it's sort of scratchpad where still valuable insights can be gained, but then more from an analysis point of view. You found some interesting things in the data, and it is much more easier to discover with an interactive environment like notebooks, and even in tools like Data IQ, where you can be much more interactive. Then you sort of browse through your data.
So what's Data IQ?
Well, that is basically
Wait, before we go, but I just want to say I completely agree with you on that. A notebook is a valuable tool and extremely valuable for finding a model, but then productionizing it, that might be a step further, because what I've seen already some companies do is because they need to productionize things in notebooks. So what they do is they then take the code from the notebooks, put it in regular Python packages that are unit tested, and then make new notebooks again where they call those Python packages. And then I'm kind of asking myself, okay, but then what are you doing?
Yes, I mean, but as a data scientist, you should keep in mind that are you making a notebook now just to get some first insight, or
exactly
do you already have in mind well, wait a minute, could potentially be already something that needs to go into production.
Yes.
I mean, there is another. I mean, so for instance, with the Databricks notebooks, what it may be is a easy way for data scientists to add code into a pipeline that's productionized, not having to know everything else in order to actually put your code in place, right? So that's,
and especially given the coming back to data maturity, given the data maturity of a lot of organizations, this is a very productive way of doing things, because they don't have the whole infrastructure and setup of doing it a more thorough way, right? So they get results much faster.
Yeah, and don't forget that notebooks, essentially, they are also just pieces of code with a lot of extra things around it. So you can also follow good coding practices in notebooks, and you put the notebooks now, you put the lab, also have nice coding help. You can open notebooks in PyCharm or Visual Studio Code, which is really professional EDA. So
in the end, it's just about running the cells in the correct order, right?
Yeah, and even now you have a nice tool, NBGather, NBGather, that if you have messed it up, it will find the right code order of cells. So, right. I mean, I heard once, I saw it on Twitter, a software engineer. He says, all those coding practices, they are nice, of course, and all those standards. But if you program with some nice, if you program in a neatly way, where you stick to good naming conventions and logical thinking and not too long functions, that's already helping a lot, right?
So that's, I mean, what we're discussing now is like maturity from the, maturity of the data scientists, I guess, and maturity of the people and the team who are implementing the solution.
Yes.
Which is different from the maturity of the company that we were talking about, and both needs to be. Yes. One is the thing that we're providing. The other thing is what the company, the environment that the company should provide for us to do our work.
Well, I've been thinking about this recently quite a lot. I guess maybe a lockdown effect, but I think a lot of companies can, on the business side, also can really benefit from a more Bayesian way of thinking, and also because Bayesian thinking, the concept is not that hard. Right, so you update your beliefs based on the data. You do hypothesis testing, and I think a lot of companies can actually benefit from this way of thinking also on the business side.
Yeah, actually, that's interesting thought.
Which I think to me is also part of becoming more data mature.
So one part of that that resonates with me is that if you let's say you run forecasts every month, and the forecasts change because data changes, because the world changes, this can be very unacceptable to companies because they want to not see the forecast jump every month and have to react and respond differently, right? So then it would be ideal if they would accept it, or if it would be more acceptable, because you have this Bayesian idea of, okay, so my belief is currently it's going to rain, then new data comes in, and then my belief is going to be updated. Well, probably less chance of rain. Instead of having this, okay, today the forecasts are this, next week the forecasts are this, I cannot trust the forecast anymore.
I mean, well, basically what you're saying is they have strong priors.
Yeah. But so strong, that so strong priors would require strong evidence in order to update them to get to the right posteriors. I think they have such strong priors that they do not accept evidence anymore into the equation.
Infinite priors.
Yeah, but so Longhow, what's your view on this?
Yeah, well, I studied statistics, and more from the other camp, frequentist.
P-values.
Well, not necessarily, but okay. The thing about Bayesian is indeed you need to have a prior, and it's just what you said. If you really have a strong prior, then your data needs to really change that prior into some quite different posterior, right? And if you don't know thing, you can say uniform prior. Well, then then you don't have a prior. and the practical thing is, only for simple models you can easily calculate new posterior distributions, and for more complex, even for not so complex models, you need some kind of simulation setup, which is computationally much more than classical machine learning or statistical models. So yeah, so I haven't really encountered them in my career, but it's not to say, of course, that they're not used.
Yeah, I guess there's a difference conceptually between the two things we're talking. So you're thinking more about the way companies should think versus you're saying more about, well, what if we use a Bayesian model to solve a data science problem, right? Or at least that's my interpretation of the two ways.
It requires different techniques, well, numerically at least in solving this, but and maybe not a lot of people have trained
on the modeling side. Sure, there's a lot of religious discussions to be had there, but I meant more on the business side, so more the way of thinking, which, you know, because at the end, for example, frequentists are also more data driven, that you are more data driven also in your business approach. I think that kind of goes hand in hand, that you base your decisions on data and also allow data to change your beliefs.
So go ahead.
I mean that's also where we talked about a couple of minutes ago on this ML ops. You monitor population drift, right? Mm-hmm. So your data has changed, so you need to update your model. That's not Bayesian, of course, but that is the way of thinking. Okay, if I see something has changed, I need to update something, right? So, and that's already a lot better than the gut feeling of a marketeer, right? Who just is not data-driven.
So how do you, when you started a new project, for example, and you encounter maybe some, well, less optimal awareness surrounding the need of this thinking, how do you approach that?
Well, I often give a simple example on how you could make money out of a model. And that's because with a machine learning model that has been trained and there is better than random, usually it is, not always, you can easily show that by using the model and selecting a group of people is better than random and better in terms of money. And that often settles the case, right? Oh, okay. Instead of just like we are doing now, mailing just random batch of people, your model mails to a different part, but the same number of people, but we get a much higher response. And you can show that from historical data. That already gives a nice incentive for people to work with a model. And then obviously you're less dependent on personal opinions from people who might leave the company, or it's much more objective. So that is my first argument always. And then of course you will always encounter people, and I've done that in the past, who don't believe in data science, who just say, okay, this is my way of selecting customers. And of course you can fight up until a certain moment. And then you can also decide, I'm not going to pick this battle, I'm going to do something else. Unfortunately, that also happens. So,
But then from there you extrapolate, for example, to also things like data quality issues, or for example, battling against data silos.
Yeah, these are the technical issues. I mean, first you need to create sponsorship from the business. Let's say marketeers who are in the business of selecting customers. They need to be involved and willing to have a model built. And then, of course, you will run into issues, data quality, or maybe data not even available. And then
you talk to your sponsor.
You talk to your sponsor, of course, and that's the thing. If he's really behind your model, then he will help you to solve this issue. But if he didn't, from the first start, he was not believing in your model, then you get an impediment. The data is not solved. 2 weeks later, and in the next sprint, it's still there, and then things are not solved, and then well, the model is not into production, and then you belong to the 60 or 80% of the data science projects that failed.
That failed, yeah. Because Ron, you mentioned the strong priors. How do you deal with strong priors?
Well, I think that so there are a couple of different kinds of strong priors that I would identify. So first of all, you have the people who don't believe in data science, that you're saying, that they believe their gut feeling more, or their current way of working more, and then well, if they're not susceptible to evidence of a model being more accurate or at least as accurate, and then have the advantage of taking work off somebody's shoulders, or being able to make sure that if somebody leaves the company, that at least there's something that is still able to do the job. But if those things are not convincing, I absolutely agree that like, at least as long as I'm not the person in the organization who needs to make sure something changes, but I'm a data scientist, then I think, okay, so at some point this battle stops for me. Then there is the fact that there are people who want to have data-driven approaches, but then they want the forecast, for instance, or the decisions to agree with what their gut feeling is saying. So there's a little bit less strong of priors, but still strong priors. And as long as your model is doing the same, then the model is perfect and great. But when the model is predicting something else, then you're gonna have to do work to show why your model may be more accurate. And I think actually that's an interesting place to be in, because if your model gets challenged,
the bias is existing outside of the model.
Yeah, well, or the bias is in the model, but as a data scientist, you were not aware of it, and somebody with strong priors who isn't domain experts might question it, and you might suddenly see, okay, I'm using a biased data set to train my model on, or I have not taken a variable into account which is critical in order to make the correct decisions, and I didn't think about this until the model got challenged. So I think strong priors from businesses can be very interesting and can improve the models, as long as the business at some point is also willing to change theirs. As soon as you say, okay, so now the model is this accuracy, if we compare it against something that's in line with what you were saying, then it's lower accuracy. And then there's a third one with strong priors. I think that there's some businesses wanna, is my experience, like you have people who want to say there's AI in my product, there's also businesses who want to say we are using a model, but then not necessarily want to have the most accurate forecast actually, or the most accurate prediction, but just want to be able to say that they're using a model, and then still have other things that they want to optimize. Something like, so weird data scientists are used to optimize for accuracy, right? But in my experience, some businesses want to rather optimize for something like stability.
I hope precision and recall.
Well, okay, yeah. we already had in our first episode a discussion about precision and recall. Well, we can have a discussion about whether businesses want to optimize for precision or recall, and then that is interesting because it will tell you what kind of errors we're more happy to make. But there are also people who are not involved at all with precision or recall or accuracy for that matter, but just with the fact that they want to have a model that doesn't fluctuate too much. There's not a lot of variance. That's also possible. And as a data scientist, I'm not sure whether you should stick to precision, recall, accuracy is everything, or if the business wants something that's at odds with accuracy, like stability, whether the data scientist shouldn't come up with solutions to adhere to that need of the business. I'm not sure where you have to be on that discussion. Do you have any thoughts?
I think you should be listening more to the business indeed. And models that fluctuate often are not good anyway, in my opinion, even if they have a higher precision, recall, lift, or whatever metric you use. And sometimes also because, suppose again, in this credit score example again, you cannot have a model that rejects a loan applicant one day and the next version of the model that person is accepted, and then in another version. So
that's very interesting. So how did you deal with that?
So you need to build in robustness in your model. A very simple example: suppose you have age as a factor, you can use an XGBoost, and if you don't care about it, then this can be very fluctuating because just it can pick up noise in in the pattern between age and creditworthiness. But if you apply restriction, let's say a monotone or strictly increasing, then of course by applying a restriction, your model will be less accurate, but it will make it more robust.
What do you mean with the restriction?
So that the relation between age and the creditworthiness or the target should be strictly monotonic, increasing or decreasing depending on the variable.
Yeah, so you're constraining the type of things that the model can learn.
Exactly. And that makes, by definition, the model less accurate because you're not allowing for every possibility. So, but in the end, you will have a model that's much more stable in the sense that it doesn't fluctuate much. And yeah, so optimizing for accuracy or any metric, well, at first thought you say, okay, that's a sensible thing to do, but you should take it into a bigger account indeed in model stability and also maybe from a legal point of perspective that you cannot take into account all the possible data that you have. So even restricting that.
Stability is also a nice metric you can monitor using MOOPS.
Yeah.
That's especially, I think, something you should also monitor in there and alert if that goes up or down.
Yeah, depending on whether you want your model to be stable or quickly changing with new data.
Well, at least you should know.
Yeah.
You know, if you should get the alert, and then how you act upon it, that's a second thing. But
yeah.
Yes, that's true, and you don't often need to have the highest accurate model in the sense that it also depends on where you're coming from. If you do nothing and you can jump from accuracy from, I don't know, from 0 to 0.7, then that's maybe good as a first step. And then an accuracy of 0.9321, maybe it's not needed, and maybe those kind of models are also way too complex.
So is that a maturity thing as well, that we're going past just the most accurate model and now start to look at different kind of needs for data science solutions with businesses, or is it something that has been always there?
It's just the KISS method. Keep it
simple, stupid.
Or Occam's razor. If you have a very complex model that doesn't add that much accuracy, why choose that model?
But I would say that does belong in to data maturity, because there's still just starting with deep learning for the sake of deep learning is not KISS.
No,
right? So I think that is a very important.
Absolutely.
Deep learning is cool, but it's even cooler if you don't have to use it.
Oh, it saves you a lot of data.
Yeah. That's a great soundbite. Yeah.
Can we talk about your shirt?
Yeah.
So people who are not here don't see the shirt, but there's a nice purple shirt with it looks like a David Bowie shirt.
Bowie,
actually.
I would say also. Yeah, very 80.
It says data rebel. That's the first word I want to talk about, and then it says data AIQ at the bottom. But let's talk about data rebel first.
Yeah, it's like I got this shirt from Data IQ. It's a software vendor for machine learning software.
We use them also.
Yeah. And the rebel in me is that I'm always challenge people. Exactly what you say. I see sometimes people starting with deep learning or complex model, and then that's just the rebel in me. I almost immediately go against it. Haven't you tried simpler things first? And also question things that sound illogic. So that's why I find this T-shirt fire suitable for me. And then also the vendor part of it, Data IQ. Since a couple of years, I'm becoming more and more fan of Data IQ, because I see now a movement where a lot of people, a lot of companies want to do data science, and I think the people who can build these models in Python or R or Scala, the coding environment. So the number of people, the number of companies who want data models, there aren't enough people with the right coding skills. And so I'm a strong believer of tools that can help you quicken this process.
So what does Data IQ do then?
Data IQ is a platform that, well, it has different angles. One angle is you can produce models much quicker without having to code in Python. So it's by using a graphical user interface. And that is where I see some opposition from data scientists, because they believe that the only way, well some then, let's not exaggerate, but that the only way forward in data science is by using coding, scikit-learn, Python, or whatever. And that's not necessarily true, especially if you believe that data science is a good cooperation between business and data scientists.
So the fact that you have both Data IQ and Data Rebel on your shirt, does that mean that advocating Data IQ as a data scientist means you're a rebel?
He's a rebel in conforming.
Well, because I think, and I, don't let me be too generalizing, a lot of data scientists, and then you can argue what is a data scientist, but a lot of data scientists, they look down towards these kind of tools, point and click tools. Their first reaction is, I'm doing things in Python, right? I mean, that's a little bit my, I'm not sure if you can confirm it, but...
no, it's true. Yeah, I see this a lot. And I also share your view that it's not always that like you say, a fool with a tool is still a fool. So it doesn't really matter. It depends on what you're trying to do. And if you can be very productive with something like Data IQ. I mean, Anchormen has used it in the past, and we will probably use it in the future as well. So just to come back to maybe to data maturity and wrap up a bit. We've seen, I think, a lot of aspects of it, from what we call corporate IT or enterprise IT, and then towards like managing technical debt. What do you think is the new frontier for enterprise IT?
Enterprise AI, you mean?
AI. Ooh.
I think enterprise AI will continue just as it has for the last years, step by step. So slow, small steps, and not a big bang. So indeed, companies will start using more and more AI. And by the way, I dislike the term AI because,
predictive modeling.
Predictive modeling, advanced analytics, but AI, I understand where it comes from. So more and more companies will start to use AI. But again, I'm repeating myself. It was said 20 years ago, more and more companies will use data mining.
Well, I see sometimes now even companies, they just call regular software development as using AI. Because they are automating a process. So it's artificial and the process is intelligent, so it's artificial intelligence.
Yeah, that's far-fetched. I mean, writing
Very
a piece of software, it's not necessarily AI. But I do see a lot of companies, they're stepping up, data-driven, and they see the benefits. So it will just continue, despite the corona crisis now. That will just continue, especially for the businesses, the normal businesses. So more conventional businesses, yeah.
Okay. Well, Longhow, thank you very much for joining us. Ron, thank you for your provocative insights, as
thank
always.
You. Yes, thanks.
Thank you, Jeroen.
Thank you for listening, everybody, and stay safe.
Thank you, Jeroen.
Thanks.
Did we inspire you? Tune in for the next episodes. Or visit our website, Anchormen.nl. There you'll find more on bootcamps, AI masterclasses, or careers. See you at the next episode.